All right, when we left each other last time, we had talked about section 2.1. I told you 2 skills for graphing. Skill number 1 was being able to locate a point on the Cartesian plane using your ordered pair. So finding our x value and our y value. We did that a bunch of times. Then I told you the second skill we needed was being able to manipulate an equation. If I give you an x value or a y value, to find the corresponding value. And we came up, this was the second graph. You can see it on my little page here. This is the second graph that we did together, and that's what we ended up with. Now, what I want to point out to you now is this, because I want to save you a little time. I don't want you, grab some graph paper and a protractor if you want. I want to save you time. I know we don't love graphing, but I want it to be something that we can at least get through in a reasonable amount of time. So there's 2 ways that we're going to see in the next couple graph papers over there. 2 ways to graph that we're going to see in the rest of section 2.1 and then in 2.2. And then we're going to use this way of graphing. So if you need something, wave your hand wildly because I'm sitting here behind the desk. So here's a couple of things I want to point out to you. This is just our last graph. There's nothing particularly special about this graph. I'm just using it because it was our example. There's 2 points of interest that I want to look at, okay, that are going to save me a great deal of time, especially when you begin doing your homework. So this first one right here, I'm just going to draw a little arrow to it, where the graph goes through the y-axis. This is called the Y-intercept. Very clever name. Mathematicians are good at naming things very cleverly. Okay, that's the Y-intercept. It's where the graph goes through the y-axis. Now, the reason I point out to you this point is because on that point, we have the ability to plug in a value that's going to treat us very well. So remembering what we talked about as far as plotting points last time, I'm sitting here at this value right here where the tip of my pen is. How far left or right from the origin have I gone to get to that point? 0. Yes. So that's what makes this valuable. For the y-intercept, the x value is equal to 0. And plugging in 0 is fantastic because 0 times anything is just 0. So that makes our life a little bit easier. Similarly, even though it's not a dot on this graph, the graph does go through the x-axis right here. That is cleverly called the X Intercept. So where the graph goes through the x-axis, that's called the X Intercept. And so similar question that I just asked. Where the tip of my pen is, it's right on the x-axis. When I go to that point, how far up or down in the y direction do I go to get to that point? Again, 0. Thank you for participating. So the value of that point is that the y value is 0. So what we're going to do is we're going to expand on our graphing that we did last time, that we plugged in values and then we got the corresponding value. What we're going to do on the next example is we are going to graph this line using the intercepts. So we are going to graph and hopefully, when we use the intercepts, this becomes a little bit of a time saver for us. So for instance, here is my example that I'm going to do, and then I have a couple for you, and then just one more thing to mention from section 2.1. So I would like us to graph together 3x minus 2y is equal to 6. All right, here goes. So what I'm going to do, let me just get a blank piece of paper to do my work on because I don't have a lot of room here on the page. So I tried to print the graphs bigger. So there's some blank space. What I'm going to do is I'm going to find the intercepts. So I'm going to make my little table, my little x and my little y table. And I'm going to find the x-intercept, which I'm abbreviating x-int. And then I'm going to find the y-intercept, which I'm going to abbreviate y-int. So here's the key to remember. When you find the x-intercept, the y value is 0. When I go to find the y-intercept, the x is going to be 0. Okay, so we're just doing what we did last time, but I'm just picking particular values. I'm picking the intercepts. Hey, Perkster, can I pick other points? Yeah, you can pick any x or y value that you absolutely want to pick. Okay, I'm just trying to create something here that's going to be a little quicker and easier because we're multiplying by 0. So my graph is 3x minus 2y is 6. So when I pick the y value 0, that is 3x minus 2 times 0 equals 6. Then the nice thing right there nice thing about that is, what is 2 times 0? It is 0. Yes, that term goes away because 2 times 0 is 0. So I'm left with 3x equals 6. And after you've probably done 1 or 2 of these, you can just put your thumb right over that instead of rewriting. Because again, the goal here is to save a little bit of time. And I end up with the x value is 2. So the x-intercept is 2 and 0. Same thing for the y-intercept, only this time I'm going to plug the value 0 in for the x. So that is 3 times 0 minus 2y equals 6. 3 times 0 is 0, so I end up with negative 2y is 6. And when I divide by negative 2, you can see how nice that works out. I end up with negative 3. So there we go. And honestly, the only time I would plug in any other point is if one of my intercepts turned out to be a fraction. Now, on the test, I'm not going to give you intercept. If I ask you to use the intercept method, one of your intercepts is not going to be a fraction. I'm just here to see, do you remember these things? But when you're working my math lab, if one works out to be a fraction, just pick another value and make sure that you feel pretty solid. So here we go. My x-intercept is 2, 0. So there it is, 2, 0. My y-intercept is 0, negative 3. There's my 2 points. I'm going to grab my straight edge right here. And again, I'm going to be nice and proud of this line. I'm going to go long direction, and then there we go. Put arrows on it. Remind everybody it goes forever in either direction, and we are done. That is the intercept method to graphing. Okay, so it has the benefit, again, you're wondering why. It has the benefit of it takes a little bit less time to go ahead and do. So here's one for you. I would like you to graph this using our intercepts, please. And so yours is 2x plus 4y is equal to 8. Graph that using the x and the y-intercept. All right, I'm going to get started on this one. Then I've got another one for you to do just to practice this little technique. So again, I've given you the instruction to graph using the intercepts. So we're going to find the x-intercept, and then we're going to find the y-intercept. To find the x-intercept, what do I plug in? 0 for which one? Perfect. It's the opposite variable. To find the y-intercept, you plug in 0 for x. Thank you for playing along. I appreciate that. So now we're just going to go ahead and do that. So when I plug in the 0 for y, I've got 2x plus 4 times 0 is equal to 8. 4 times 0 is 0, so I have 2x equals 8. And when I divide by 2, the x value is 4. So that's the x value I'm going to plug in right there. Do the same thing. I'm going to plug in the x value 0. So 2 times 0 plus 4y equals 8. 2 times 0 is 0. That's the whole benefit to the intercept method, is the arithmetic works out a lot smoother. And I have the y value 2. Any questions, comments, or concerns about what's going on here, what we're doing? Please interact with me. I know it's still early in the morning. You're tired. It was a long weekend. But please, if you got a question, ask it. Okay, 4, 0 is the x-intercept. So that's this point right here. 0, 2 is the y-intercept. That's that point right there. And now we'll connect the dots. And it looks something like this right here. Perfect. There's my graph. All right, one more problem. Do this problem as well using the intercept method. And it looks like this. I would like you to do 6x plus 4y is equal to 12. Oops, you can't see that because I didn't slide up. 6x plus 4y is 12. And do this using the intercept method. All right, so once again, I'm going to find the x-intercept and the y-intercept. So the x-intercept is what I get when I plug 0 in for y. The y-intercept is what I get when I plug in 0 for x. So when I plug in 0 for y to find the x-intercept, I've got 6x plus 4 times 0 is equal to 12. 4 times 0 is 0. And so what we end up with here is the x value of 2. And then the other one, when I plug in the x of 0, I've got 6 times 0 plus 4y equals 12. 6 times 0 is 0. So once again, 4y is 12. And when you divide, we've got y equals 3. So there we go. And now I'm going to plot those 2 points. The first one's 2, 0. The second one's 0, 3. And that's my lovely line right there. There's one more thing in this first section to talk about before I leave the intercept method. Anybody got a question? Anything to add? Anything we need to clarify here? Okay. Well, I'm going to trust that you're telling me the truth. There's no reason not to, because I love questions. All right, the last little bit from this section has to do with some special forms of a line. So let's say that you are asked to graph this. Let's say you have the line y is equal to 3. Now, what can you identify as different about this equation of a line compared to any of the other equations of the lines that we've had up to now? A little hint, how many variables are there? There's only one variable. It's missing an x variable, okay? So I'm just going to make that note right here that what do I do when I'm missing the x variable? Well, let me make my little table of values like we did last time. So here's my table. I'm going to have x values. I'm going to have y values. So let me pick my x values. Let me pick the x value -4. Let me pick the x value 0 and the x value 3. Okay, so there's my table of values. Now here's the question I have for you. According to this equation right here that I've written down that says y equals 3, if I tell you the x value is -4, what does this equation tell you the y value is? 3. Okay. If I tell you the x value is 0, what is the y value? Perfect. You're catching on. 3. One more time. If the x value is 3, what's the y value going to be? Perfect. Okay, this equation right here says no matter what, the y value is always going to be 3. So that leads us to one of our two special cases of a line. So the y value is 3. So I've got -4 and then 3. So boom, there's a dot. 0, 3, boom, there's a dot. And 3 and 3. And you could plot as many other points as you want. Yes. I picked those. I gave those to you. We could have picked any x values that you would have wanted. Okay, my point here. So this is a great clarifying question. The question is, where did the -4 and the 3 come from? Those were just the values I picked in my table. And the point here is that no matter what x value you pick, all this equation says, all it refers to is the y value is going to be equal to 3. So in your table, if you had picked the x value 9, then the y value is going to be 3. That's always going to be the response here. Okay, so yes, any number you fill. In fact, that is true of any equation of any line. If you like this intercept method that we just did here, I was just pointing you in the direction of some particular values that are easy to plug in, but you can always plug in any value you want for x or for y, and it'll work out. Because that's what the graph is representing. The graph represents the relationship between the x's and y's, so even the points that you didn't pick would be on here. So if I had picked, for instance, here, what's one that's gonna, if I picked -4, okay, then if I plug that into the table, then I should get 1, 2, 3. I should get +4 right there because it's on the line. So that just represents all the relationship that we've just graphed. Okay, really great questions. Thank you so much for asking it. Now, as I'm connecting these dots right here, does anyone know what we call a line like this that stays pretty steady as we're going left and right? Okay, that's fair. This is called a horizontal line. And if you want to, okay, I don't know how much math trivia you want to remember. I try to minimize the amount of trivia that I make you remember. But if you ever see an equation that is missing the x value, that it's y equal to a number, it's always and every time, no matter what, going to be a horizontal line. So this is y equal to 3, and it's a horizontal line that's been lifted up 1, 2, 3 units, make a horizontal line. So on that same grid, if I said, okay, let's see, what if I said, let's graph y equal -2? Well, it's a y equal to a number. So what kind of line is that going to be? A horizontal line. And that's going to be a horizontal line that I drop down 2 units. So I'm going to go down 1, down 2. And there we go. And I'm going to make a nice, cute horizontal line right there. It's a lovely, lovely line. There it is. There's my line y equal to -2. I'm going to label it because I know most of you don't have various colors. And I want you to be able to distinguish the different graphs when you get home. So just do this for me. I'll give you 15 or 20 seconds to do it on pick another grid, it doesn't matter where, and I would like you to graph the line y equals 6. I am going to ask you to do this on the test that we have next week, so I'm hoping that this is free points. Yes, there's plenty of graph paper over there. Just help yourself as you need it. So you're graphing y equals 6. Okay, so if you needed to make the table like I did with that first example, that is fantastic. I hope you did. But if you didn't need to, if you said, oh, he just told me a moment ago that when it's y equal to a number, that's always going to be a horizontal line. So here's my ruler. It's in a horizontal line. And so I'm going to go up 6 units to right here to y equals 6. And I'm going to draw my horizontal line right there at y equals 6. It can be that quick and easy, or if you need to make a table because you just want to verify, go ahead and do it. Either way, whatever is best for you as you are navigating the test. All right, we are almost done with section 2.1. I've got one more thing to mention to you, and then we will be done. The second thing to mention is this. Well, let's say that the other variable is missing. Let's say that I have x is equal to, let's say 5. Whoops, you can't see that. There it is. That's better. Let's say I have x equal to 5. So this time there is a missing y variable. I'm going to make a little table. But when I go to pick the values, this equation says no matter what is the only x value that matters on this graph? 5. So if the x value is 5, this equation says nothing about the y value, so I can pick any ones that I want. So I'm going to pick the y value -3. This says x has to be 5. Okay, so 5, and then the y value, let's just say, is going to be 1. And then the x has to be 5. So 5, and let's say the y value is going to be, let's say, 7. Doesn't matter, just trying to pick different numbers so I don't get in a rut. So this equation is saying the reverse of the previous one. This one's saying the x value has to be the same every time. The y values are not defined by this equation, so let's see what happens. I've got the point 5 and -3, so down 3. 5 and 1, so up 1. And 5 and 7, up 7. So this time, instead of a horizontal line, does anyone know what this kind of line is called that goes straight up and down? Yes, this is called a vertical line. And again, making a table will always work every time, no matter what. But if you can remember a little bit of trivia, because we will talk about horizontal and vertical lines again in our next sections. If you can remember a little bit of trivia, anytime you're missing the y variable and you just have x equal to a number, it is always a vertical line. So last problem from section 2.1, if you would please, I would like you to graph what is x equal to -4. What does that look like? X equal to -4. All right, so there's no y variable. So again, if you made a table, your table looks something like this, okay? And making a table is totally a fine and handy thing to do. In your table, all the x values are -4, and then whatever y values you pick, your line and my line are going to look exactly the same. Or you could just remember, when there's no y variable, that means I'm going to have a vertical line, and it's going to be back 4. So here's my vertical line, my ruler. I've slid it back 4 units. And so here is my graph of that line. This line represents every point we could ever think of that has an x value of -4. That's what the graph tells me. And that is all we've got for that section. So let me stop the recording here, and we'll start a new one for the new section that we're going to talk about.